بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're going to talk about numerical sequences. Before we talk about numerical sequences, let's remember together some formulas which are related to order in R. A, B, C, D, M, P, and Q are real numbers and N is a natural number. For operations. Well, if A is smaller than B smaller than C, then we can add D to the three terms. So we can say that A plus D is smaller than B plus D is smaller than C plus D. We can also subtract D. So we can say that A minus D is smaller than B minus D is smaller than C minus D. We can multiply by D if D is positive. So AD is smaller than BD is smaller than CD. But if we multiply by D, which is negative, we have to flip the boundaries of the inequality, so it becomes CD smaller than BD smaller than AD. So this is what we mean by flipping. A was on the left side becomes on the right side, and C was on the right side and it becomes on the left side. So this is what happens when we multiply by a negative number. Similarly, for division, if we divide by a positive quantity, nothing changes, whereas if we divide by a negative quantity, we have also to flip the boundaries, as you see. Now, what happens to the nth power and nth root? If A is smaller than B smaller than C and all are positive, then we can say that A power n is smaller than B power n is smaller than C power n. Now, if A is smaller than B is smaller than C and all are negative, we can also say that A power n is smaller than B power n smaller than C power n, and all of them are negative in case n is odd. Whereas if n is even, we say that 0 is smaller than C power n smaller than B power n and smaller than A power n. Remember, because if m is even, all of these numbers, when we raise them to an even power, become positive. Now, if A is smaller than B smaller than C, then we can say that the nth root of A is smaller than the nth root of B is smaller than the nth root of C. This happens if n is odd, whereas we can say that the nth root of A is smaller than the nth root of B is smaller than the nth root of C if n is even, providing that all the real numbers are positive. Now, reciprocal. If A is smaller than B smaller than C, then 1 over C is smaller than 1 over B is smaller than 1 over A, providing that A, B, and C have the same sign. In other words, if all of them are positive or all of them are negative. So in case we want to use the reciprocal, we have to flip the boundaries. A on the left, C on the right becomes 1 over C on the left and 1 over A on the right, and providing that all real numbers should have the same sign. Now, operations on two inequalities. If A is smaller than B smaller than C and M smaller than P is smaller than Q, then we can add. We can say that A plus M is smaller than B plus P is smaller than C plus Q. But remember, we cannot subtract. What will happen in subtraction, we will see. Now, if all of them are positive, we can multiply. So we can say AM is smaller than BP is smaller than CQ. Now, we cannot here also divide, and if some of them are negative, others are positive, we cannot use this strategy. Now, comparison of A squared 1 over A and the square root of A. In fact, if A is between 0 and 1, the higher the power, the smaller becomes the number. So A squared would be smaller than A, smaller than the square root of A, which is also represented by A to the power half, which is smaller than 1, which is represented by A power 0, and smaller than 1 over A, which is represented by A to the power negative 1. And if A is 1, all of these quantities would be equal. And if A is smaller than 1, the higher the power, the higher the number. So 1 over A would be smaller than 1, smaller than the square root of A, smaller than A power 1, smaller than A power 2. And you can also go on saying that it's smaller than A3, A4. Let's see this example together. x is bounded between 1 and 2 and y is bounded between 5 and 10. The question is to frame x squared minus 2y. Remember, if x is between 1 and 2, we can square because all of them are positive, so x squared would be between 1 and 4. Now, if y is between 5 and 10, we multiply by negative 2, so we have to flip the boundaries. It becomes negative 20 and negative 10. And by now, we have x squared and minus 2y. We add them together, we can add. So if we add, we get x squared minus 2y is between 1 minus 20 and 4 minus 10. And finally, x squared minus 2y is bounded between negative 19 and negative 6. Let's see this application. Try to do it alone. The question is to frame x minus 5 over y. Let's see the solution. X is between 1 and 2. So x minus 5 is between 1 minus 5 and 2 minus 5. You can subtract, nothing changes. Or x minus 5 is bounded between negative 4 and negative 3. So this is the first part, which is the numerator. Now if we multiply it by a minus, we get minus x plus 5 is between 3 and 4. And now we will see why we multiplied by a negative 1. Now y is between 5 and 10. This is given. Remember, we cannot divide, so we apply the reciprocal here. We get 1 over y is between 1 over 10 and 1 over 5. And in fact, we can apply the reciprocal because all are positive. But remember to flip the boundaries. Now, if we multiply, we get minus x plus 5 times 1 over y is between 3 times 1 over 10 and 4 times 1 over 5. In other words, we have this form. So minus x plus 5 over y is between 3 over 10 and 4 over 5. And remember, this is not what we want. We want x minus 5 over y. So we can multiply by a minus by flipping the boundaries. So that's why we applied this step here. Because if x minus 5 is between negative 4 and negative 3, it means that all of these values are negative, whereas all of these values are positive. So we cannot multiply them. In case we want to multiply, all numbers should be positive. Now, comparison in R. A and B are two real numbers. To compare A and B, you can use two different methods. The first method is the difference method. So we compare A minus B to 0. If A minus B is less than 0, we can say that A is smaller than B. And if A minus B is greater than 0, we say that A is greater than B. And if the difference is 0, we say that A is equal to B. We can also use the quotient method, in which we compare A over B to 1 when B is positive. So if A over B is smaller than 1, we can say that A is smaller than B. If A over B is greater than 1, we say that A is greater than B. And if A over B is 1, we say that A is equal to B. But remember here, B should be positive because we cannot cross multiply unless B is positive. Well, let's see. N is a natural number and N is greater than 6. The question is to compare 5N plus 4 and 6N minus 2. If we subtract using the difference method, we get minus N plus 6. Now, if N is greater than 6, so N minus 6 is positive or minus N plus 6 is negative. We can automatically say that 5N plus 4 is smaller than 6N minus 2. Now let's compare these two quantities. If we divide, we get 3, which is greater than 1. And remember to specify that the denominator is always positive, which is B here. And 3 power n plays the role of B, and 3 power n is always positive. So compared to 1, this is greater than 1, we can say that 3 power n plus 1 is greater than 3 power n. Mira or Rami? While n is a natural number, we need to compare these two quantities. Mira found the difference, applying the difference method, which is 1 over this quantity. She specified that n plus 2 is positive and n plus 1 is positive, being natural numbers. So the whole difference is positive, or we can say that n plus 1 over n plus 2 is greater than n over n plus 1. So Mira used the difference method. Well, let's see what Rami did. Rami used the quotient method, which is like this, but n squared plus 2n plus 1 is greater than n squared plus 2n. The numerator is greater than the denominator, and the denominator is positive. This means that if the numerator is greater than the denominator, means that the quotient is greater than 1. So you could also deduce that n plus 1 over n plus 2 is greater than n over n plus 1. Now, which method do you prefer? I think both methods are correct, but pay attention to state all the required conditions. Thank you.